Okay, sorry, I started the recording late. For those just checking in, the answer for this is 2. Number 1 is 2. Number 2 is what was it, 55? 75, 55, yep. Number 3, I think most of us agree that it's C. I think it's C. Number 4 is 60,000, and now we're on number 5. Okay, so any answers for what the line for the y-intercept of the line of best fit means?
I think it's C, sir.
You think it's what? C?
Yes, sir.
Okay. And does anyone agree or disagree?
I would agree with that answer.
Okay. Can you guys explain why you think
I
it's C?
think it's A.
A. Okay. I'm open to any explanations.
So what makes this thing a
I
bit
think
tricky
it's
because oh, what makes this thing tricky is because it starts not at the edge of the graph, but somewhere in the middle.
Wait, what was that?
All right, the reason why I'm not 100% certain of my answer is because it's tricky, and what makes it so is because it starts in the middle of the graph rather than at the end or at the very beginning of the graph.
Okay, yeah, but you can predict where it will be at the end. No? Just extend the line. Just extend the line. Like that. That's where it'll
Yeah.
be. Someone says C, someone says A. Can you explain to me how you got those answers, please?
okay. I got A because from what I know, the Y
You're breaking up. So we can't hear you. You can type in the chat though.
the X value is a 0. So at the y-intercept for A, it says the predicted average shopping time in minutes of customers at the
Mm-hmm. Okay, so yes, the answer is indeed. Okay, so at the y-intercept, which is down here, right? The score discount will be 0, and we will have an average time of it's looking like 7.5, something like that, right? So what that tells us is that at 0% discount, the average shopping time will be 7. A says the predicted average shopping time in minutes of customers at a store with no discount. So A is the answer. So you were correct, person who said A. B, talking about 50% discount, that is way up here. That is not a y-intercept. Y-intercept is where x equals 0, okay? That's the y-intercept. The predicted increase in the average shopping time in minutes for each 1% increase. Can anyone tell me what that would actually be? This figure right here. See, what's a name for this? What is this describing?
Smoke,
Huh?
smoke.
Huh? I can't hear what you're saying.
I'm asking if it's a slope.
Yeah, I can't hear. I don't hear what you're saying. You're
Even if it's average, I'm thinking it's the slope.
yes, it's a slope, but what's a yeah, slope gradient, whichever. That's what that is, not the y-intercept. The predicted average number of customers that are stored with notice. No, it said nothing about number. Okay, let's look at number 6. The scatter above shows the relationship between revenue and advertising expenses for 16 companies. The line of best fit is also shown. Which of the following is the best interpretation of the meaning of the slope of the line of best fit? This one should be easier now, considering what we just went over.
I think
Someone
it's
said
the
A. Huh?
I see.
C. The expected increase in advertising expenses for every $1,000 increase in revenue.
Yes,
Why do you think it's that? Well, your audio quality probably won't allow us to hear why you think it's that. Um, but I disagree. Any other guesses? Someone said A. Why do you think it's A? You agree with B? Okay, you need to explain your answers. I'm not just gonna take answers.
Sir?
Yep.
Yes, sir. I chose B because based on what the starter plot is showing, it's showing that it literally showing that for every time that the expected revenue increases, so does the advertising expenses.
Okay, think about it. Think about this logically. If you have a business, if you have a business, right, and your revenue is increasing, um, is that telling you that you need to up your advertising? Like, which of these comes first? You increase your advertising and you make more money, or you make more money, so you have to increase your advertising.
Well, I'd say that you increase your advertising so you can make more money.
Uh-huh. So, what does that mean about what you said?
Ooh.
Okay, whenever you see a graph, right, the x-axis is always the variable that you set, right? It's the variable that you set or the one that you're measuring against. So it can be time. In this case, it can be something like your advertising expenses. Like you decide how much money you spend on advertising, right? The y-axis will always be the one that is out of your control, or what is changing in response to what you're measuring for. So in this case, revenue, right? Like a business cannot decide that they want that they're making $150,000 in revenue. That is decided by the market or how well they are doing. They can't just decide that. They can decide how much is spent on advertising, but not how much on revenue. Therefore, any answer that says any answer that says the expected increase in advertising expenses for every $1,000 increase in revenue, um you can have an expected increase in advertising expenses. Like you decide that. You can expect revenue. That's not something that you decide. So C would be out. And remember, a way to remember this is that the formula for a gradient or slope is rise over run. It's the change in y over the change in x, right? So in this case, for example, let's use 150,000 and 20 and 100,000 and 0. So the y-intercept here is 100,000. And so that means that when revenue is on the y-axis, right? For a $50,000 increase in revenue, you had to spend $20,000 in advertising. That means it's roughly for every 50,000 you have to spend 25. Means it's roughly at 2,000, or what did I say? Two and a half. Is this 2.5? Is it 2.5? Changing the y 50. But yeah, 2.5 is the gradient of the slope right here. So every dollar you spend in advertising, you will get a 2.5 increase in your for every dollar. You'll get $2.5 for every $1 you spend on advertising. No, the difficult part means that this is between A and B, right? So A says the expected increase in revenue for every $1 increase in advertising expenses. And B says the expected increase in revenue for every $1,000 increase in advertising expenses. And between these two, I really don't know. I really don't know which one it is, because
Sir.
the way I would calculate it is that I would factor in the 1,000. And so it would be for every $1. It would be for each dollar increase in. So I would either say for each dollar increase in advertising, you can see $2.5 increase in revenue. Or I would say for each $1,000 in advertising, you can expect $2,500 in revenue.
Understood, sir. I get it now. The reason why you chose A over B is because both axes are in the same unit, as in $1,000. If you
Exactly,
flip them
right?
together, they would reduce to one each.
Exactly. Yeah, that's my dilemma. But here's something interesting. With B and C, right? Both of them have this for every $1,000, right? And typically when people are making multiple choice answers, they want an answer where something there's one thing wrong with it, or like it's completely far off, right? So for answer A, they have the for every $1, right? For answer B, they have the $1,000 and it is like half correct. For C, they have the every $1,000, right? So I'm like, they put that every $1,000 for an incorrect option and a half correct option. So does that mean that that B is the correct option because A is wrong? Because it doesn't have the $1,000, or is it just another trick or something to ignore? I won't give you the definitive answer, but I'll tell you this. At the end of this book, there are the answers. The answers are down there. I can guarantee you that it's either gonna be A or B, right? But I would say A personally, but I can't tell you that you're wrong if you put B. So you can check the answers if you want, but I'm not gonna do that. So the scatter plot above shows the plots of the lengths of 15 movies against their box office sales. The line of best fit is also shown. Which of the following is the best interpretation of the meaning of the slope of the line of best fit? So A, the expected decrease in box office sales per minute increase in movie length. B, the expected increase in the box office sales per minute increase in movie length. C, the expected decrease in the box office sales per 10-minute increase in the movie length. Or D, the expected increase in box office sales per 10-minute increase in movie length. Expected, okay. Which of these is it, Jane?
Choice B. Trust me.
B, the expected increase in box office sales per minute increase in movie length. That's what I think. I agree.
B.
Yep. Okay, in a psychological study, researchers asked participants to each complete a different task for a cash prize, the amount of which varied from participant to participant. The results of the study, as well as the line of best fit, are shown in the scatter plot above. Which of the following is the best interpretation of the meaning of the y-intercept of the line of best fit?
A.
A. The expected decrease in the number of mistakes per dollar increase in cash price. Any other answers?
Yes, sir. C.
C. The expected dollar amount of the cash price required for a person to complete the task with 0 mistakes. Any other answers?
The reason is because its intercept is 0. And if you think about it from a logical standpoint, the less mistakes you make, the more value your work. So it fairly adds up.
What? I didn't catch that. Repeat that. You were busy in some parts.
I said, for one, the SY intercept is 0, according to the line of method, or somewhat 0. That's basically
Yeah, I can't properly hear what you're saying. Okay, so if when you're being asked about y-intercepts, anything with per or for every is out. Because the y-intercept means what is going on at 0, right? So or something relating to none. So any A and B are relating to rates, and the y-intercept has nothing to do with rates. It's like the set value or the ground position. So that is out. With regard to C, the expected dollar amount of the cash price required for a person to complete the task with 0 mistakes. The y-intercept. Okay, is the y-intercept down here, or is it up here?
Up to the top, sir.
Okay, it's up here, right? So up here, what price? What mistake number is it heading towards, or what price is it heading towards? Whichever of those.
Sir, B has gone to the dumpster. D makes a lot more sense
because it's more mistakes for less money. So
Yep. So yes, the answer is D, because at the y-intercept, the price is $0. $0. Right? So the expected number of mistakes a person makes in completing the task when no cash price is offered. When $0 are offered, the person makes like 55 plus mistake. That's what it's saying. The expected dollar amount of cash price is required for a person to complete the task with 0 mistakes. So that figure that you're talking about, the 0 mistakes, it is down here. So that's gonna be like $700, $800, $900 is the amount of money someone would need to be offered to make 0 mistakes. So C is out for that reason. That's not the y-intercept. That is actually the x-intercept or a route. Well, x-intercept. I won't call it a route. So for that reason, D is the answer. Is there anyone who doesn't understand this? Please clarify before I move on.
I thought it was A, but after understanding what you said, I see why the answer is D.
All right, so number 9. The scatter plot above shows the fat content and calorie counts. I don't know why I keep inputting my own words into these sentences. And calorie counts of 8 different cups of ice cream. Based on the line of best fit to the data shown, what is the expected increase in the number of calories for each additional gram of fat in a cup of ice cream? So what is this question asking for? The mathematical term, what is it?
It's asking for the rate of
Yes. Is there another word for a rate of increase when we're talking about graphs?
acceleration.
I didn't hear what you said, but slope,
Acceleration.
rate, and yeah, acceleration works too. Slope, acceleration, gradient, whatever. Well, velocity, not acceleration. Unless- let's not talk about acceleration here. Yeah. Then what?
Sir,
That depends on what on the x-axis. Yeah, go ahead.
sir,
Yep.
so I believe the answer choice is C.
See? Why? How did you get that?
Well, sir, it's asking for what is the expected increase in the number of calories for each additional gram of fat in a cup of ice cream.
Mhm.
But on the y-axis, you can see that in the total calories, it goes up by 20 each time for additional grams of fat in cup of ice cream.
Mhm.
So the rate, so if it's asking for the rate of increase, the rate of increase is 20 calories.
Okay, does anyone disagree? B. You have to explain, please. Hello, you're breaking up. If you can type in chat, that would be great. I understand the internet because you guys are, some of you are halfway across the world, some of you just have bad internet. That's fine. I won't knock you for it. But please type in chat. Yeah, go ahead.
I chose B because the question asks for the rate of increase per gram. It said for each additional gram. So we're not trying to find per 20 grams, we're trying to find per gram. So it would be B
Yep.
because I use 320 and 20. So I divide 320 by 20 and I got 8. So 8 grams.
Okay. Any other answers?
So the answer is sir, B. I did the calculation.
Okay.
Sir, all right. For example, explanation. Y2 minus Y1 x2 minus x2 give us the slope. So I did it with the most accurate looking one. So the 380 matches with the 25 and the 340 matches with 20. 380 minus 340 leaves 40. 25 minus 20 leaves, hold on.
Okay. That is how you do it, by the way. Even if you got the answer incorrect initially, you're on the right track. So when you're being asked for a slope, don't do any guessing. You do this. You use this formula. And yes. So you look for 2 points that are convenient. For example, here we have 340 and 20. And we have 420 and 30. So 340 and 20, 340, 20, 340 and 20, 340, 20. And we have 420, 30. So we have 340, no, 340, 20. And we have 420 and 30. And this is equal to 80, right? 420 minus 340 is 80. over 10, which is 8. Eight. So that's how you do it. It's the gradient formula. Did I talk about it in this specific chapter? I mean, even this shouldn't be if you're past grade 9 or 8, this shouldn't be your first time hearing about this formula. They don't talk about it in this chapter, but it's a well-known formula for anyone who has done anything like this. Okay, let's see how many more questions. Okay. Okay, so the scatter plot above shows the amount of nitrogen fertilizer applied to 8 oat fields. Applied to 8 oat fields and their yields. The line of best fit is also shown. Which of the following is closest to the amount of nitrogen applied in pounds per acre to the oat field whose yield is best predicted by the line of best fit?
Choice
B.
B, how do you get that?
According to the line of best fit, we see a 250, and it is the closest actual point to the rest of
Great.
the
So
best fit,
the
making it the
closest
most
point,
accurate.
sorry, cut you off there. You broke up, so I assume you were finished speaking. My apologies. Okay, it's the closest line to the best fit and of any of these, and it's 350 pounds per acre. Okay, number 11. The scatter plot above shows the distribution of the seats for the restaurants in 7 different mall food courts. The line of best fit is also shown. According to the data, what is the total number of seats at the food court represented by the data point that is furthest from the line of best fit?
Five, choice B.
What did you get that?
I multiplied the 7 by the 80, and 540 is close to 560, choice B.
You guys see that?
Yes, sir.
I did the same.
Great. Good try. You got it. Researchers must conduct an experiment to see whether a new vaccine is effective in relieving certain allergies. They have selected a random sample of 100 allergy patients. Some of the patients are assigned to the new vaccine, while the rest are assigned to traditional treatment. Which of the following methods of assigning each patient's treatment is most likely to lead to a reliable conclusion about the effectiveness of the new vaccine? Any guesses?
Sir, my
B.
guesses lie between C and D. I'm not sure yet, but I'm sure A and B are on it.
Great. Good answer. So it's either C or D. We all agree on that, right?
Yes, sir.
Uh-huh.
So D.
Huh?
D.
Why? Why D?
Because you'd have an even amount of patient in each room, so because it's 100 patients, then
Wait, you said B? You said B as in boy?
dog, B as in dog.
Okay. D. Okay. Okay.
Yes, I would go with D as well.
Okay. Why not C? I'm curious.
Well, with C, it said that a coin is tossed to decide which groups receives the new vaccine. But a coin now is a variable. When another coin is tossed, there's no way to really be sure of whether it lands on heads or tails. But with the numbers, you can know who gets an even number and who gets an odd number.
Sir, I also agree with C, and I have a reason.
Go ahead.
All right, sir. As Jerome just explained, it's partly unreliable with the C. But with D now, we have a better chance because each person assigned a random number on where they are. It's like, say, you are standing in line. You get an odd number, I get an even number, the other guy gets an odd number. However, with the Tracy, when they divide themselves even in two groups, the groups are they're saturated, means one bunch gets it and the other half doesn't get any of it, while in the other one, it's more uniform. Am I making any sense right now?
Yeah, you are. Okay. I this one's tricky. I would say D too, as in dog. Um Wait, never mind. It's C. It's C. I didn't see this right here. It says each person is assigned a random number. If it's a random number, then the random number, those with an even number are assigned. I feel like if there's a random number, there's no guarantee that that there's an even number in each group. But I'm not sure. I would check. I would check the answers for this one. Or maybe huh?
I get how you get that. It's finally making sense now. It's a random number. It didn't say a random number between 1 and 100.
Yeah, like if it like lined the patients up, then it assigned them a number, and then you did even or odd, then you would have an equal number in each group, and it would be pretty much random. But if you do like a random number, then you don't necessarily get like an even split, right? Maybe you do, but okay. Subject selected at random and subjects not randomly assigned. Results can be generalized to population. Cause and effect cannot be proven. Example, researchers want to see whether medication X is effective in treating the flu. People with the flu from the general population are randomly selected. They are given the choice of a new medication or a traditional medication. More people in the medication X group experience a reduction in flu symptoms. We can generalize that people who choose to receive medication X fare better than those who don't. However, no cause and effect relationship can be established because the medication was not randomly assigned. We don't know whether the reduction in symptoms is due to the medication or a difference between those who volunteered and those who did not. And it's this question. Each patient is assigned. Okay, I would go with D, since it's a more random, it's more random assigning. And statistically, if you truly assign numbers randomly, and there's a cap on the numbers, right? As someone said, it's only 100 of them, right? If it were, I was gonna say, okay, the numbers are assigned randomly, right? When the numbers are assigned randomly, about 50% will be even and about 50% will be odd, right? About, not necessarily true, but it is still more random than like having persons splitting themselves into two groups, because because someone in the group might be like, okay, that guy who I came here with went into this group, so I'm gonna go with him, or some other weirdness like that, right? Where if you're just assigned a number and the number is even or odd, then it's more random. Like there's no personal decision going on there. Okay, a basketball manufacturer selects a random sample of its basketballs each week to ensure a consistent air pressure within them is maintained. In week 1, the sample had a mean air pressure of 8.2 pounds per square inch and a margin of error of 0.1 pounds per square inch. In week 2, the sample had a mean air pressure of 7.7 psi and a margin of error of 0.3 psi. Based on these results, which of the following is a reasonable conclusion? Most of the basketballs produced in week 1 had an air pressure under 8.2 psi, whereas most of the basketballs produced in week 2 had an air pressure under 7.7 psi. B, the mean air pressure of all of the basketballs produced in week 1 was 0.5 more than the mean air pressure of all the basketballs produced in week 2. Okay. The number of basketballs in week 1 sample was more than the number of basketballs in week 2 sample. It is very likely that the mean air pressure of all basketballs produced in week 1 was less than the mean air pressure of all basketballs produced in week 2. What do you guys think?
I don't know, not a tricky one.
Okay, let's eliminate some. Okay, it's very likely that the mean air pressure of all basketballs produced in week 1 was less than the mean air pressure of all basketballs produced in week 2. Week 1 was less than week 2. Is that correct?
No, sir.
Nope. The number of basketballs in week 1 sample was more than the number of basketballs in week 2 sample. There's no way to know that. He didn't say anything like that. It could even be more. Who knows? The mean air pressure of all basketballs produced in no, let's do A. Most of the basketballs produced in week 1 had an air pressure under 8.2 psi, whereas most of the basketballs produced in week 2 had an air pressure under 7.7 psi.
I think that makes any sense.
I didn't hear what you said.
A doesn't make any sense. My reasoning being, if it's under 8.2, how could it be an average? Not for something to be an average, some has to be the number.
Precisely. You're right. So A is out, C is out, D is out, meaning B is the last one left. And B actually makes sense if you read it. The mean air pressure of basketballs produced in week 1 was 0.5 psi more than the mean air pressure. Because it uses mean, then it's correct. Like if it didn't say mean, like if it said like each ball produced in week 1 had 0.5 more psi than each ball produced in week 2, that would be incorrect, right? Because there's a variance. So since it says mean, then it's correct. Number 4.
Sir.
Yeah.
Sorry, yeah, it's because actually I subtracted the mean amount of ball pressure from week 2 from week 1, and the answer was 0.5.
Yeah, that'll work. But you still gotta do elimination sometimes. A student is assigned to conduct a survey to determine the mean number of servings of vegetables eaten by a certain group of people each day. The student has not yet decided which group of people will be the focus of this survey. Selecting a random sample from which of the following groups would most likely give the smallest margin of error?
Choice C, it's the largest sample size.
Huh?
Choice C, the largest sample. All right, for example, a city is around 2,000 people, somewhere around. Certain restaurant that's around 100 is that much. Students who follow the same diet plan, that's really hard to gauge because people have different tastes. Viewers of the same TV show get that sense because remember TV shows go by thing like worldwide or citywide, so it's the largest possible number.
So which one would give the smallest margin of error?
Choice C.
C?
Largest. Yes, sir.
Okay, what do you understand by margin of error?
Margin of error is
Someone in the chat said B. Okay.
the measure of the probability of mistake.
Okay.
And if that's true, C can't be answered.
So you go with C because it has the largest group of people, right? Basically. Yep. I agree with that. I agree with you. So the thing with margin of error is that like the smaller the sample size or the more messed up the sample size, like if it's too specific, then you're gonna have a larger margin of error. It's like if you go with students who are following the same daily diet plan, then it won't give you like a mean number of serving of vegetables. Okay, you can get a number of the servings of vegetable eaten, right? But you're gonna have a much smaller number of people who are following the same daily diet plan, and so you won't be able to. You won't get. Yeah, you can get meaningful results, but you will have a larger margin of error simply because you have less people to work with. So the less people to work with that you have, the greater the margin of error. Like if you want to find out who's gonna win the next US election, and you survey 10 people, right? And 5 say one guy, 5 say the other guy, then you're gonna say there's a 50% chance of this person winning. And the margin of error you're gonna have is like 1, because it can be like 0.5, like half a person in either direction. But if you interview like 1 million people, then it's gonna be like a much smaller margin of error, especially if you do it like across all kinds of demographics, then you'll get a much smaller margin of error. Now let's see if the information here about setup, it says anything about margin of error. Confidence interval. So here we have it. The larger the sample size and the less variable the data is, the lower the margin of error. Yep. So I think, okay, so Malden is a town in the state of Massachusetts. A real estate agent randomly surveyed 50 apartments for sale in Malden and found that the average price of each apartment was 150K. Another real estate agent intends to replicate the survey and will attempt to get a smaller margin of error. Which of the following samples will most likely result in a smaller margin of error for the mean price of an apartment in Malden, Massachusetts? So 30 randomly selected apartments in Malden, 30 randomly selected apartments in all of Massachusetts, 80 randomly selected apartments in Malden, or 80 randomly selected apartments in all of Massachusetts. The answer is C. The margin of error refers to the room for error we give to an estimate. For example, we could say that the mean price of an apartment in Malden is 150,000 with a margin of error of 10,000. This implies that the true mean price of all apartments in Malden is likely between 140,000 and 160,000. This interval is called a confidence interval. To get a smaller margin of error, in example 4, we should first only select from apartments in Malden. Selecting apartments from all of Massachusetts will not only introduce more variability to the data, but also strays from the original intent of the survey, which is to find the average price of Malden apartments. Okay. So yeah. With that being said, yes, viewers of the same television show. Wait, same television show? It said show, not channel. Hmm.
Sure.
Yeah, it's a little tricky between A and C, but
Yeah.
Very.
because with a television show you can have certain people can prefer a television show based on the type of people they are, and they can also they care about eating vegetables. But with residents of the same city, um you're gonna you can have all types of people in a city. Hmm.
It sounds more plausible though.
I would go with A, but I can't give you a definitive answer, unfortunately. The length of a blue-spotted salamander's tail can be used to estimate its age. A biologist selects 80 blue-spotted salamanders at random and finds that the average length of their tails has a 95% confidence interval of 5 to 6 inches. Which of the following conclusions is the most appropriate based on the confidence interval?
All right. For one, we know that B is out.
What?
For one, we know that B is out
Why?
because it says of all salamanders, and our prompt says blue spotted salamanders.
No, but oh, you mean D is out? Yeah, D is out. And I would say A and B are out because based on what I remember, that's not what confidence intervals is about. We can briefly touch upon it. Even though this meeting is ending really soon. Confidence interval 95%. It doesn't go in detail, and because you guys don't need it for this level of statistics. But okay, if you don't know what a confidence interval is, don't worry, you'll never need to calculate one. All a confidence interval does is tell you the true mean or some other statistical measure for the population is likely to be. Even though the SAT only brings up 95% confidence intervals, there are 97% and 99% confidence levels. The higher the confidence, the more likely the true mean falls in the interval. So in the example above, we can be quite confident that the true mean pH for all forest rainfalls in the past years between 3.2 and 3.8. So going off that, the answer is C. The true average length of all the tails of all blue spotted of the average length of the tails of all blue spotted salamanders is that between 5 and 6 inches. Number 16. An economist conducted research to determine whether there is a population between a relationship between the price of food and population density. He collected data from a random sample of 100 US cities and found significant evidence that the price of food in lower places is lower in places with a high population density. Which of the following conclusion is best supported by these results? Okay, so I can tell you this: C and D are out. You can establish cause by numbers. That's a whole different thing. You can establish association or correlation, but not causation. So C and D are out. So is it a positive association or a negative association? So based on what it said, he collected data from a random sample of 100 US cities and found significant evidence that the price of food is lower in places with a high population density. Lower, higher. That's a negative association. So the answer is B. And that's it for statistics 2. So that being said, thank you all for attending the session. I hope you're more familiar with this topic. Again, if you have any questions about specific topics, feel free to message me. And if you want to know the answers to the ones that I and you guys were unsure of, you go all the way down here, and you will find the answers. So for statistics 2, here are some of the answers. Okay, B, as we said, confidence interval. C, that is correct. Variability. They went with D. Selecting students who follow. Okay. So the answer was D. We weren't even close.
Hmm.
Makes sense though. That makes sense. C. Answer C is correct because the greater the sample size, the better the margin of error. It's interesting.
Sir,
Yep.
thanks a lot for a very invigorating math session. I've learned a lot more about statistics than I usually do in my ad math classes. Thanks a lot and hope to see you again next time.
Yeah, definitely. All right. It was nice hanging with you guys, but here are the answers. I got a couple of them wrong. My apologies for that. But to be fair, I don't remember a lot of SAT questions being on this type of statistics. So you guys will be fine. All right, I'll see you
Never
guys
mind,
next week or the week after, but there will be a session next week, most likely.
Thank you very much for your session.
All right,
Anytime.
and goodbye.